This unit is on correlation and regression, and our goal is going to be to describe and to model the relationship between two quantitative variables, an explanatory variable, an x, and a response variable, y. So we're going to describe to say what we see, and also to figure out a way to mathematically model that relationship. So examples: how is the size of a house related to its price? Here, the size is the explanatory variable. We usually think of that as explaining the price. Or how is the mileage of a used car related to its price? And again, we think of the number of miles it has as being as explaining the price of it. Or how is college GPA related to ACT scores? Again, college ACT scores in this case is the explanatory variable, and we expect that to explain or to predict the college GPA. So first we'll talk about correlation in this video. Let's look at the scatter plot, which shows the relationship between the size of a house, finished square feet, and the price in thousands of dollars. And this was for some homes in Cambridge, Wisconsin. And the picture shows just what we'd expect. Bigger houses cost more. On the other hand, for that same town, this shows how many days, the size of the house on the x-axis still, and now how long it's been on the market, the days. And here, there doesn't seem to be any relationships at all. So this first one seems like a strong relationship. There's really something going on. Here it's pretty weak. So we want a way of measuring that. The way to do that is with what's called the correlation coefficient. It's called Pearson's R, and it's a measure of the strength and the direction of the linear relationship between two quantitative variables. And remember, this is only talking about quantitative variables. We have no way of talking about the relationship between a person's favorite color and the kind of car they drive, or their academic major and their favorite hobby. So we need the variables to be quantitative, to be numbers. So the correlation coefficient is always a number between -1 and 1. It's mathematically forced to be between -1 and 1. If it's close to -1 or close to 1, that means a strong relationship. Close to 0 means it's a weak relationship. There's almost no relationship. And we'll see examples of all of this. So, for example, the size and price was a very strong relationship in our picture, and the correlation coefficient turns out to be 0.91. The size and the days in the market was a very weak relationship. Turns out to be a correlation coefficient of 0.19. So the correlation coefficient is a measure. It's a number which we attach to the relationship between two quantitative variables, and it gives us an indication of how strong they are, how strong the relationship is. Now here, there's a very strong relationship between the x and the y. If you know x, you can predict y perfectly, basically. But the correlation coefficient is close to 0. And the reason is that the correlation coefficient is a measure of the strength of the linear relationship, of how well the data fits on a straight line. And here, even though the relationship is strong, it's not at all linear. Now, what about the sign of R? So we said that R could be between -1 and 1, but what's the difference? Well, a positive relationship means that as the explanatory variable increases, so does the response variable. Larger houses cost more, on average. That's what you expect. And a negative relationship means that as the explanatory variable increases, the response variable decreases. So when you're talking about the price of used cars, the more miles on the car, the less the price. And we see that here. So this is some Honda CR-Vs that were for sale, all the same make and model, but not year. And the number of miles on the car is down here, the price is up here. And as we'd expect, the more number of miles a car has on it, the less it costs. And the correlation coefficient is negative. In fact, negative 0.88, which is, again, very strong. So we've got a separate PowerPoint on how to find correlation coefficients and how to, a separate screencast on how to find correlation coefficients and how to make this correlation matrix. So this correlation matrix shows all the correlations between two or more quantitative variables. So here we get price versus finished square feet, price versus days on the market versus finished square feet all at once. And that's just useful for seeing lots of correlations all at the same time. And like I say, there's a separate screencast on sort of how to do the details of that in Excel. To do that, you'll need the data analysis toolpath, which I also take you through. Okay, so here's some examples to strengthen our intuition. We see these 6 scatter plots along with their correlations, coefficients, and this one down here looks like a big cloud, no relationship at all, and in fact the correlation coefficient is close to 0. Here it's strongly negative, like our cars and miles. Here's it strongly positive, like our size and price of houses. And here are a couple moderate relationships, one positive and one negative. So by looking at these slides, you ought to be able to get a general idea of where the correlation coefficient is just by looking at the scatter plot. You ought to at least be able to tell whether it's positive or negative, or close to 0, and whether it's really close to 1 or -1 or not so close. There is a formula for calculating R. You see that it involves the individual x's, so the individual, say, home sizes, and the mean of the home sizes, and the standard deviation of the home sizes, and then these are the prices for those homes. We're not going to worry about the formula. We'll have technology calculate it for us. Maybe in class we'll talk about why this formula makes sense. But for now, just know that there is a formula. And in the old days, we had to do it by hand, usually barefoot in the snow. Okay, so in our next screencast, we'll talk about linear regression. We've seen here that when there's a strong correlation, a straight line seems to fit the data pretty well. And in the next screencast, we'll talk about how to find the line that fits it best.